This is an excerpt from a conversation with Emil Jacobs, Yuan Lee, and Nathan Lewis, moderated by Andrew Revkin, brought to you by the Chemical Heritage Foundation's annual T.T. Chow Symposium.
Lola from Hastings High School had a kind of a related question, digging in a little more precisely on one aspect of the renewable energy portfolio.
Okay. Do you personally believe that solar power will be as productive as advertised?
That's a great question. Maybe we'll start with Dr. Jacobs.
I'd punt it to Nate.
Nate.
Nate's the...
Over to you.
Oh, there are two things that I think we have to keep in mind here. One, that we do need a way to make solar technology that can really get to scale. What you mean by scale is if you wanted to get 10 or 20% of our energy by 2050 from solar panels, we would have to install about 1 million panels on roofs every single day from now until you're 55 years old. So we can't do that when there are these big glass museum pieces that you have to have people install. We have to find ways to roll it out or paint it on so that anybody can do it anywhere. And we have a solar carpet, solar paint day, and you go paint your roof and then hook it up. We need technology that's fundamentally different than what we have now to make it get scale as advertised. And the second point is the sun has this nasty little habit. It goes out locally every single night. President Gerald Ford said that solar energy isn't something that's just going to come in overnight. And he was right, the president. We have to find a way to store it so that we can take advantage of the fact that it is by far the biggest resource known to mankind for energy. It's bigger than 15,000 nuclear power plants running for a year is the amount of sun we get in 1 hour. So we have nothing close to the champion of energy in the solar system. And we just got to find a way to capture it cheaply and store it to deliver energy, to get it to live up to its advertised billing.
Just to build on Nate's comment, if I were looking for a technology breakthrough that I would think would have a huge impact, it would be in the battery area, battery storage or storage of energy. And it has multiple effects, all of which are positive. The one that Nate pointed out is very good. It would allow you to take solar energy, which is on during the day and off at night, and you've got a way to store it. That also translates into how you manage the entire electric grid for a city or a country, because there's a lot of sources that are intermittent. PV is one, wind is another. So it allows you to kind of have sources come in that aren't constant. It also allows you to change significantly the transportation sector. If you had battery technology that you could have low cost, durable, quick charge capability, the transportation sector would change significantly. So if you were looking for some breakthrough technologies that would really make a difference in a lot of different areas, a step change improvement in battery technology would be high on my list.
So they should fund that innovation hub, huh, Nate?
Yeah, but you know, there's a way to store energy that is much higher energy density than the best battery by a factor of more than 20. That's in chemical fuels like the stuff that ExxonMobil sells. The energy density in gasoline is 13,000 watt-hours in a kilogram. The best battery is only 200. Wow. So the best way we know how to store energy is in chemical fuel and chemical bonds. So I'd rather take the sun and not store it in a battery. I'd rather store it in chemical fuel. Plants figured it out. We're smarter than a plant. We should be able to do better.
The plants just were working on it a lot longer than we were, so
that's right.